How's it going, everybody? Mr. D here, and this is going to be the last and final video for Unit 1. How fun, Unit 1. And we're going to be graphing systems of linear inequalities. This is going to be just like solving systems of linear equations, but now with inequalities. Instead of having a solution point, we're going to have a solution region. All of our graphing is going to be very, very contingent on these little inequality symbols here. That's going to tell us two things. Are we going to be using a solid line or a dashed line? And are we going to be shading above or below our graphs? When we're shading these, we're going to look for where does our shading overlap. That's going to be our solution region. All right, so first one, I've got y is less than 3x plus 5. So this symbol here, less than, tells me it's going to be using a dotted line. If it doesn't have the underline portion, it's going to be a dashed line. And since it's less than, we're going to be shading underneath. So let's graph. My y-intercept is 5. Whoop. And I'm having trouble graphing properly. Yay. Try that again. Y-intercept is 5. There we go. And slope is up 3 over 1. Or I could get more points backwards by going down 3 backwards 1. So then we're going to take our straight edge and we are going to connect the dots with a dashed line. Not a solid line, a dashed line. So what this means is any point on the line is not necessarily included in our solution region. However, everything underneath this line would be, because it's a less than, so we'd shade underneath. All right, next one. We've got y is greater than or equal to negative 4x plus 1. So greater than or equal to, it's got the little underline, so I need to use a solid line when I graph it. And since it's greater than, the shading is going to go above. We'll use red for this one. So my y-intercept is 1. My slope is negative 4, so I'll go down 4 over 1. I can repeat this process however many times I want. I could go backwards and go up 4, backwards 1. Once I have sufficient points, we'll grab a straight edge. We'll connect the dots again with a solid line because of that inequality symbol had the or equal to portion. And once we have that line graphed, we're going to shade above. So if I go any point on this line and look up, that would be the above direction. So now what we want to focus on is the overlapping region, the solution region, where both of those shadings occurred. And that is going to take place where we see both the red and the blue in this region right here. And I'm not going to color everything in, that would take forever. So what that says is any point in this region would be a solution for not one but both of these inequalities. So if I chose this point right here, 3, 8, if I plug in 3 for x, 8 for y, 3 for x, 8 for y, that's going to work for both of them. Same thing down here. If I chose 1, negative 1, that's in the shaded region. That would work for both. If I chose this point right here, 0, 5, that would not work because it's actually on the dashed line. If it's on a dashed line, it's not going to be included. Flip side of that is if I chose, say, this point right here, 1, negative 3, it's on a solid line. So if it's on a solid line, it would be included. All right. Onward we go to number dos. That's Spanish for numero 2. All right, we've got two inequalities. First one's written in standard form. Not too thrilled about that. So let's rearrange this first guy. We'll move the x value to the other side. So that'd be negative 2x plus 10. I'm not too thrilled about having a 5 attached to the y, so I need to divide that out. So this would be y, plain old y, greater than. Again, this symbol would not have to flip around because I didn't divide by a negative 5. I just divided by a positive 5. Negative 2 divided by 5 doesn't turn out clean, so we'll just call it negative 2/5. plus 10 divided by 5, that's just 2. So that's the inequality we're going to graph. Okay. Onward we go. The second equation is already in slope-intercept form, so not a whole lot I have to do there. Let's get to graphing. First equation, we've got a y-intercept at positive 2, and our slope says we go down 2 over 5. Down 2 over 5, and I can do that however many times I want until I have sufficient points. The fact that we have the inequality symbol of a greater than tells me two things. Dotted line, because it doesn't have the little or equal to portion, and shading above the line. So I need a dashed line, and I'm going to shade above it. So dashed line, shading above. Dashed line, and then shade above. So I like to make those little swipe marks there. And I'll fill that in later once we figure out what's going on. All right, second one. We've got y is less than or equal to 3/4 x minus 2. So we've got a y-intercept at negative 2. My slope is going to be 3/4, so up 3 over 4. And I can repeat that however many times I need to get additional points. Or I could go backwards, down 3, backwards 4. As soon as I have sufficient points, we will connect the dots. We're using a solid line for this one because it had the or equal to clause in there. And it was a less than, so we're going to shade underneath this thing. So then just like before, we want to figure out where do the shading parts overlap? And that would be this little sector right here. And it would go on forever and ever towards the right, but we're obviously not going to shade forever. Once I know where it's going to overlap, you can get rid of all of this other stuff if you want to. You can leave it as long as it's not in the way. Doesn't matter. So again, any point in this region is going to be a solution to not one but both of these inequalities, with the exception of points that are on this dashed line. Points on the dashed line are not included. Points on a solid line are included. All right, that's all I've got. We are now done with Unit 1. How fun in the sun. You know the drill. If you have any questions, please let me know. As always, folks, good luck. Have fun. Be safe. Roll Tide.